So we're going to talk about frictional forces a little bit, and we've mentioned them in the sense of just that's one of the forces that opposes motion, like air resistance, drag, and then friction. We're going to talk about it in a little bit more detail. So friction is a force that opposes motion, and there's two basic kinds. There's kinetic friction, and that's what acts once an object is moving, and there's static friction that is acting on an object that is in place or stationary. And the static friction is generally greater than the kinetic friction. And you'll have experienced this because when you're trying to move something or get something started, it's always harder to get something moving than to continue it moving once it's going. And that's because of the kinetic and static friction difference. The friction is going to depend on the two materials in contact. There's a lot of things that are very, very low friction, Teflon, ice, things like that. And then you have the high friction things, sandpaper, rubber, wood that's not polished. So you get the idea that rougher the surface, the more friction you're going to get. And friction also increases with normal force, or the amount of force pushing the two surfaces together. Hopefully all that makes sense. And the coefficient of friction is just a unitless number that belongs to those two materials, and you'll see them listed. The two equations that you need for friction are almost identical, except you're just keeping track of, is it kinetic or static friction? So it's the force of friction is equal to the coefficient of friction times the normal force. So here's a quick example. You and a friend are trying to move a 1,000 Newton couch across a carpeted room. You are choosing to push it across the room, not pick it up and carry it. And so what force is required to start the couch moving if the coefficient of static friction is 0.85? Set up the equation, plug things in, and you end up with a nice straightforward. The static friction is 850 newtons. And so in order to get something moving, you're going to have to push with something greater than or equal to 850 newtons. And then once you get it moving, you notice it takes about a third less force to keep it going, which means it got easier. And then now we want to find out what the coefficient of kinetic friction is. Same equation, only this time you're using kinetic friction. And we know that it's 1/3 less the force is equal to the coefficient of kinetic friction times the normal force, which is equal to the weight of the couch. And then you end up with a coefficient of friction that is less than the coefficient of static friction. Nice, straightforward algebra. So now that you've seen the nice, straightforward algebra, I thought I'd show you something a little more complicated. We're going to have a sled with a rider going down a rough hill, and coefficient of friction between the sled and the icy hill is 0.15. The sled and the rider have a mass of 60 kilograms, and I'm asking what is the acceleration of the sled. The slope of the hill is 25 degrees. So all that information is there. You have the coefficient of friction is 0.15. You have a mass of 60 kilograms, and you have the angle of the incline. And we start by setting up our force equations, the perpendicular piece and then the parallel piece, and it really doesn't matter which way you go. If you don't have enough information from one, you go ahead and set up the other. I just happen to start with a normal force, and that's equal to the perpendicular piece of the weight, which is mg cosine of 25. From that we find the normal force, which we will need for our friction piece. And then we're looking at the parallel part of the forces, and so that net force, which would be the mass times the acceleration of the sled down the hill, is equal to the parallel piece of the weight minus friction, because friction's working against it. So you have ma is equal to mg sine theta minus the kinetic, or the coefficient of kinetic friction, times the normal force. And you plug all those numbers in and do some algebra, and you end up with an acceleration of 2.8 meters per second squared. Once again, just like every other force question, it comes down to figuring out where the forces are, figuring out what you need finding the coefficients and plugging things in based on the, in this case, perpendicular and parallel forces. All right, good luck. Bye-bye.